Hello everyone, welcome back to my channel Shraddha's Physics. Today we will continue with the mathematical physics, the part 3. This is from core 8 part. We are dealing with the complex analysis. Today our topic is the operations with the complex number and some properties related to the complex number. Let us see the fundamental operations with the complex number. First of all, we will see the addition. In this operation, so let us consider there are two complex number, that is suppose z1 equal to x1 plus I by 1 and z2 equal to x2 plus I by 2. These are the two complex numbers which we want to add. So, in the addition we have to add the real part. So, the z1 plus z2 will be equal to this z1 plus z2 equal to x1 plus x2, this is the real part, plus iota, iota means the imaginary part, y1 plus y2. So, this is the basically the addition. Now, similarly for the subtraction, we have to just subtract z1 minus z2, that is equal to, similarly for the real part, this will be x1 minus x2, x1 minus x2 plus iota y1 minus y2. Okay. Now, for the multiplication, we have to multiply z1 with the z2. So, I am directly writing that you can see that during every operation, that is addition, subtraction, multiplication, division, every operation we have to take the real part first, that is x1 x2, this will be, you can see this will be x1 into x2, and when you will multiply this I into I, that will becomes I square will be becomes minus 1, I means here the iota, so this will be minus 1 into y1 into y2, so this will be minus y1 into y2 whole of, again the for the imaginary part plus iota, here you can see that when iota will multiply, this will be iota y1 into x2, you can see y1 into x2 and here x1 into y2 plus this will be x1 into y2. So, this is for the multiplication. Again one more thing is that when you are multiplying the conjugate number, that is suppose I am writing here, suppose z equal to x plus iy and our complex conjugate z star is equal to x minus iota y. So, in this case when we will multiply this z with z star, that will be equal to x plus iota y into x minus iota y. So, here this will be this is in the form of a plus b into a minus b. So, that will be a square means this is your x square minus b square means here iota y whole square. So, that will becomes this is x square, I square becomes your minus 1. So, this minus 1 becomes plus 1 into y square. So, this is the purely a non-negative real number. So, here you can conclude that when you multiply a complex conjugate number with a complex number, you will get a non-negative real number. Okay. Now, we have to calculate the division, that is z1 divided by z2. Similarly, here this is x1 plus iota y1 divided by x2 plus iota y2. Here you have to multiply the complex conjugate of x2 plus I y2, that will be the first term, this is x1 plus I y1, it remain as it is, divided by this is x2 plus iota y2. We have to multiply the complex conjugate of x2 plus I by 2, that is x2 minus I by 2, and we will divide this by x2 minus I by 2. So, that if I will cancel this two term, it will remain as 1. So, now this becomes, you can see that this two number, this one and this one, this is in the form of a plus b into a minus b. So, that if you will multiply these two number, they will become a real number. So, this will becomes, here you can write x1, I am writing directly, I am multiplying this as x1 into x2, this will be x1 into x2, again this iota becomes minus 1, here is the minus 1, so this becomes plus y1 into y2, I am writing the real part, plus this is iota y1 into x2, so this will be y1 into x2 minus of, again you can see this will be y2 into x1, so this will be y2 into x1 whole divided by, this will becomes x2 square, you can see this is x2 square plus this will be y2 square, okay, this is 2, x2 square plus y2 square. Now you can separate these two equation, that is x1 I am writing, this is simply we can write this is x1 plus x2 plus y1 into y2 divided by x2 square plus y2 square, plus this will be again iota y1 into x2 minus y2 into x1 divided by this much x2 square plus y2 square, okay. Now we will see this number 5, that is equality of two complex number. So that is z1 is equal to z2, in which case, so here we are writing z1 as x1 plus iota y1 and z2 as x2 plus iota y2. So the two complex numbers are said to be equal when the real part, when these real parts are equal, that is x1 should be equal to x2 and the imaginary parts are also equal, that is y1 equal to y2. So in this case, when the real parts are equal and the imaginary parts of the two different complex number are equal, then these two complex number must be equal, okay. So in the simple word we can say that the two complex number are equal if and only if their real part and the imaginary parts are separately equal, okay. So from the above operation we conclude that whether it may be addition or subtraction, multiplication or division, in every case we find that these are the complex number. Whether after the addition operation it is a complex number, after subtraction you will see this is the real part and imaginary part, so this is the complex number, and in every operation, that is addition, whether it may be addition, subtraction, multiplication or division, in every cases you will find that these are your complex number, okay. Now we will discuss some properties of the complex number. So first of all we will see the addition is commutative in nature. Commutative means if we will add the two complex number, that is suppose z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2, if I will add these two real number, sorry, the complex number z1 plus z2, so that will becomes z2 plus z1, so this will becomes z2 plus z1, so this is called the commutative property. So here you can add these two real number, that is sorry, two complex number z1 plus z2, that will be x1 plus x2, I am taking the left hand side part, x1 plus x2 whole into, plus this will be iota taking common, this will be y1 plus y2, okay. So here we can write that this is x1 plus x2 equal to, this is equal to x2 plus x1, plus I can write this will be iota y2 plus i1 also I can write, okay. Otherwise I can write this as x2 plus iota y2, this is one term, plus this is x1 plus iota y1, I can write like this, okay. Now this is your z2 and this is your z1. So here you can prove that z1 plus z2 equal to z2 plus z1. So here the complex number follows the commutative property of addition, okay. Similarly we can check for the associative property. Associative property means z1 plus z2 plus z3, that will be equal to z1 plus z2 whole into plus this is z3. So it means that if we will add z2 plus z3, z1, z2, z3 are the three complex numbers. So if we will add z3 is similarly x3 plus y3. So if we will add the z2 plus z3 first, then with z1, then that will be equal to adding z1 plus z2 first and then adding with z3, you will get the same result. So this satisfies the associative property of addition. Okay. Similarly, we can check for the commutative property of multiplication, that is z1 into z2, that will be equal to z2 into z1, where z1 and z2 are complex number. Similarly, for the multiplication is multiplication property for the associative law, that will be z1 into z2 z3, that will be equal to z1 z2 into z3 whole into z3. So this is the associative property of multiplication, also it satisfies. And similarly, if we will check for the distributive law, so this is equal to z1 into z2 plus z3, that will be equal to z1 z2 plus z1 into z3. This is the distributive property. Now we will see the additive identity of complex number. It means the additive identity means if we will add any number with the complex number z, then we will get the same number, that is the complex number z. So it means that if we will add 0 with the complex number z, we will get z. So 0 is known as the additive identity. Okay, 0 is known as the additive identity of the complex number z. So here also we can write what is the additive inverse. Additive inverse means if we will add minus z with the z, then we will get 0. So here the additive inverse is minus z. Here I am just highlighting this. Additive inverse is minus z and additive identity is 0. Similarly, for multiplicative inverse or multiplicative identity, first let me tell you what is multiplicative identity. If we will multiply 1, if we will multiply 1 with the complex number z, then we will get z. So this one is called, this is called the multiplicative identity of the complex number. And similarly, if we will multiply z with 1 by z, we will get 1. So here this 1 by z is called, this 1 by z is called the multiplicative inverse of the z. Okay. So let us calculate the multiplicative inverse, that is suppose we are writing here z equal to x plus iota into y. So here we know the multiplicative inverse is 1 by z. So the 1 by z equal to, I can write this as 1 by x plus iota into y. I can write like this. So here I cannot write the complex number here. So I have to multiply its complex conjugate, that is x minus iy, in the denominator and the numerator. So this will becomes like this. So now multiplying this, we will get here x minus iy and divided by a plus b into a minus b. This is in this form. So this will be x square plus y square. Or also we can write, separating the real part and the imaginary part, x by x square plus y square, and this will be minus iota y by a square plus y square. So if in the question it is directly given that, for example, it is given z equal to 2 plus 3i, then you have to calculate the multiplicative inverse. Then you have to directly write 1 by z equal to x means here 2 divided by a square plus y square means 2 square is 4 and 3 square is 9. 9 plus 4, that is 13, minus I, y is here 3. So 3 divided by 13. So this is the multiplicative inverse of 2 plus 3i. So you can write like this. Now suppose z is your x plus iy, and we know its complex conjugate z star is what? X minus iota y. Okay. So if I want to calculate, suppose let us add these two numbers, that is z plus z star. If I will add these two numbers z plus z star, what will, this will be 2x and iota y get cancelled. Iota y get cancelled if I will add. So that implies x will be equal to 1 by 2 of z plus z star. So this is the real part, that is x is in the real part. So x will be equal to 1 by 2 of the complex number. This is the sum of the complex number and the conjugate of that complex number. Similarly, here z equal to x plus iy and z star is x minus iy, and if I will subtract, then what will happen? So let us see, this will be z minus z star. So z minus z star will be equal to x get cancelled. So this will be equal to iota y. So this will be twice of iota y. So here also I can write y will be equal to 1 by 2i of z minus z star. Or also, if I will multiply I in the denominator and numerator, this will becomes minus I by 2 into z minus z star. Or simply we can write this is I by 2 of z star minus z. So this is the representation of a real part and imaginary part with respect to the complex number and in the form of complex number and its complex conjugate. So this is all for today. Thank you.